Today's video comes in 3 parts. Hi, I'm Vincent, and here's the what, the how and the why of 3D printing. Let's start off with what 3D printing actually is. It was supposed to be the third industrial revolution, some said. Now, while I do agree that 3D printing opened up a revolutionary production process, calling it an industrial revolution in 2020 is a bit overdone in my opinion. Especially when you consider the technique is being around for literally decades already. During university in the 90s, where I studied industrial product design, we already got familiar with 3D printing. Although I must agree, in those days we weren't calling it 3D printing, we would call it rapid prototyping, as it usually was not meant to produce a final product. Now, generally speaking, there are 3 fundamentally different types of 3D printers. The most common these days in the consumer market is called FDM printing, fused deposition modeling. A plastic filament is molten and pushed through a nozzle. The nozzle moves up and down and round and draws the outline of your design. Now, by stacking up these super thin layers while slightly changing the drawing each layer, you are able to create almost any geometry you can think of. One of the most flexible methods of 3D printing is SLS, selective laser sintering. This is also quite a bit more expensive. Where FDM melts plastic and then spits it out, SLS lays down a bed of powder of the material you're printing in, and then high energy lasers selectively melt the powder so it locally solidifies. This method is incredibly useful to also create metal or aluminum or even titanium parts. A third method worth mentioning is increasingly getting more popular: SLA, stereo lithography. A light-sensitive liquid resin is layer by layer being solidified by also a set of lasers. But in this case, where 2 laser beams cross, there's enough energy to solidify the resin. The solid object is being pulled like magic from a liquid. If you see it, you have to see it for yourself. Now, the common thing about these 3 different methods of printing is that they all work in layers, very thin layers. So 3D printing is best viewed as like normal printing, but then over and over again on the same sheet of paper. So how does it work? Before you can print anything, you need to know what you want to print. And for that, you need a 3D design that is actually printable. There are several websites where you can download 3D models for free, like Thingiverse or Yegi, Wedgie. On these sites, enthusiasts share their designs for anyone to freely download and print. But things get really exciting when you learn the software to create your own 3D designs. I use Rhinoceros and 3ds Max, which are commercially available. But there are some really good 3D modelers for free that will get you started, like Blender or Fusion 360 and SketchUp. I believe it's free to try. Okay, after you created the virtual model of your design, you need to prepare it for printing. This means a couple of things. First, you have to orientate the design so that the part will actually fit in your printer. But also, orienting your part wisely will increase the strength of the result. Because the part has all these very thin layers, it is relatively easy to break in that direction. So depending on the direction forces run through your part, you should also choose the print orientation that will best support that. Also, you need to consider the forces of nature, like gravity. If your part is top heavy on one side, guaranteed it will topple over during the printing process and your part will fail. Or when there are loose parts inside the print, they will not float in midair. So if you need these parts to succeed, you also need to create support structures. But more on this later, because it sounds difficult, it isn't anymore. Once you finish your design and you are satisfied with the placement, you can then export it so you can slice it up. Yep, we're gonna slice it up. Slicing is the word that they chose for creating the code with which the printer knows what to do. It states every path the printer has to follow and when to spit out plastic, but also how warm the machine needs to be to melt the plastic. The slicing software that came with my machine is the most advanced in the business. They say so themselves, so it must be true. The cool thing about this slicing software is that it analyzes the model and it is able to figure out if it actually needs support structures. And if so, it automatically adds them to the code. So as I said, it sounds difficult, but it's easy peasy, lemon squeezy. Now, because the printer I have has two print heads, it can print two different materials. This enables me to print two colors in the same part. Or, for instance, one of the nozzles can print specifically designed support material, like this water-soluble support material that, as the name suggests, dissolves in water after the print is finished. And this saves a lot of time cleaning up the part when it's done. But it also allows me to print incredibly complex geometry with floating parts inside enclosed structures. Like this ball inside a ball inside a ball. Ain't this awesome? So why do you want to get a 3D printer? There are a gazillion reasons as to why someone might want to use a 3D printer. For me, there are three core reasons why I actually bought one. The first reason is it builds on my creative skills as a 3D designer. Seeing a design on screen and being able to look around it from any angle is already a major leap forward as opposed to 2D drawings on paper. But to actually hold a design in your own hands adds a whole new dimension. Literally. Talking to clients and teammates is so much more efficient when a physical part's on the table. I can also quickly iterate between all sorts of versions of a design. It saves so much headaches in the long run. Secondly, being schooled in technical engineering, I have learned the power of the prototype. Often, when you come up with a more or less original solution to a construction problem, it has to be tested to prove it actually does what it needs to do. Making prototypes allows for quick assessment of points of failure or usability issues or ergonomics. Now, as you might know, I also love woodworking. And because of that, my knowledge of the stuff goes way beyond theoretical facts of wood. Being able to extremely accurately produce plastic prototypes will definitely contribute to my theoretical understanding of plastics. Oh, by the way, plastic has a very bad reputation these days as it is destroying our oceans. In general, as a designer, working at the very start of almost every product development process, you really need to embrace your responsibility and use materials smart. That is why, for instance, I almost always use PLA in my prints. Usually it's strong enough, but it's also biodegradable. So there, stop judging me. And last but not least, 3D printing is so much fun. In recent years, 3D printers have gotten so good and reliable, not to mention affordable. When you have designed an object, printing it now is effortless. Sure, a print will fail every now and then, but in my experience, albeit limited, that's the exception. As a designer, I am trained to think in solutions instead of problems, and every obstacle I encounter is considered an opportunity. Having a 3D printer now often makes those solutions and opportunities tangible and practical instead of gathering dust on my hard drive. It actually starts to make sense to even start thinking about weird little things to keep cables tidy, or improve the monitor mount on top of my camera, or think of a multifunctional mount for my grey card, or make the perfect little container for rechargeable batteries. Not to mention the crazy piggy bank for our son, where you can actually see how much money you have saved up. Man, I'm having a blast with this thing. I also hope that you enjoyed this video. If so, stay tuned, or rather, subscribe, to get more videos about design, creativity and what it can do for your organization. Thanks for watching, and I'll see you next time. Bye.